Rutherford's alpha ray scattering experiment. After the discovery of fundamental particles, that is electrons and protons, a problem was arised, that is, how these fundamental particles are arranged in a small place in an atom, because atom is the smallest particle which cannot be seen with our naked eye. So in such a small place, how these fundamental particles are arranged? Because electrons are negatively charged particles and protons are positively charged particles. There are certain repulsive forces that exist among the same charge particles, and there will be an attractive forces that exist in between electrons and protons. Irrespective of these forces, how this much number of particles were present in a minute place called atom. So to find the secret behind the arrangement of these particles in an atom, so many scientists have conducted so many experiments, but a successful experiment was conducted by Ernest Rutherford. In this experiment, Rutherford has taken a radioactive element radium as a source of alpha particles. This radioactive element was kept in a lead box, and the alpha particles emitted from this radioactive element was allowed to pass through lead plates which are having some slits, and these alpha rays were allowed to fall on the thin gold foil. Around the gold foil, a circular screen was arranged to identify these alpha particles. This screen was coated with zinc sulfide. When alpha particles struck on this screen, we'll get scintillations. With the help of those scintillations, we can identify the position of alpha particles, that is, in which direction the alpha particle has traveled. The microscope was also arranged to identify these alpha particles, that is, to record the position of these alpha particles. This alpha ray scattering experiment, Rutherford observed the following three things, that is, most of the alpha particles pass through the gold foil without any deviation on their path. Some alpha particles are reflected in different angles. Out of 10,000 or 20,000, only 1 or 2 alpha particles have maximum repulsion and reflected back on their own path. From these three experimental results, Rutherford concluded the following. That is, most of the alpha particles pass through the gold foil without any deviation on their path, indicates that most of the space in an atom is empty. Let it be the atom. Most of the alpha particles are passed through the gold foil without any deviation on their path, indicates that most of the space in an atom is empty. And the second observation is, some alpha particles are reflected in different angles. Some alpha particles are reflected in different angles. Alpha particle is a 4 units mass and 2 units positively charged particle. 4 units mass, that is heavy mass, and 2 units positively charged particle. Repelling means a positive charge more than its charge and a mass more than its mass may come closer to the alpha particle. Then only an alpha particle can repel. Suppose if only one proton is present isolatedly, it cannot repel alpha particle. Rather than the proton will repel. But here proton is not repelling. Alpha particle is repelling. Alpha particle can repel only when a particle which will have more charge and more mass is came into its path, then only it change its path. That means the whole positive charge and mass of this atom is concentrated at a minute point. This minute point is said to be nucleus, and probably this nucleus may be present at the center of the atom. So, alpha particles which are away from this positively charged nucleus will pass through the gold foil without any deviation on their path. So, when this alpha particle is away from the nucleus, there will be no change in its path. But when it comes closer to the nucleus, then there will be a repulsion and change its path. So the magnitude of repulsion will depend upon how close it is. That means if it come closer to the nucleus, there will be more repulsion and there will be a more reflection. That's why most of the alpha particles are reflected in different angles. Those alpha particles which are directly bombarded at the center of the nucleus will have maximum repulsion and get back on their own path. Here we have three results. That is, when alpha particles pass focused on the gold foil, most of the alpha particles pass through the gold foil without any deviation on their path. That means most of the space in an atom is empty. Some alpha particles are reflected in different angles. That means the whole positive charge and mass of an atom is concentrated at a minute point, which is known as nucleus. Probably it may be center of the atom. So those alpha particles which are come nearer to this nucleus will get repelled and change their path. That's why they are reflected in different angles. Those alpha particles which are directly bombarded on the center of the atom will reflect back on their own path. From these three conclusions, Rutherford makes a new theory to explain the structure of an atom. This theory is known as planetary model of an atom. Rutherford's planetary model of an atom. Rutherford's planetary model of an atom. From the results of the alpha ray scattering experiment, and after analyzing the results, Rutherford proposed that in any atom, the whole positive charge and mass of that atom is concentrated at a minute point called nucleus. Minute point called nucleus. Because at the time of this Rutherford's alpha ray scattering experiment, neutrons were not discovered. But he imagined that certain other particles with certain mass may also present. They may also present along with these protons in the nucleus. Now, the negatively charged electrons will revolve around these positively charged nucleus, just like planets revolve around the sun. We know in solar system there are nearly 9 planets which are revolve around the sun. Like that, in an atom, the electrons will revolve around the nucleus, just like planets revolve around the sun. So what is the purpose of this revolution. Because we have already discussed, there are certain attractive forces between oppositely charged particles. This nucleus is a positively charged particle, whereas electron is a negatively charged particle. If electron is in a stationary mode, it should fall into the nuclear attraction, and ultimately it will fall into the nucleus, and atom should decay. So to overcome this attractive force, this electron will revolve round the nucleus. What happens? What is the use of this revolution means? When an object is revolving in a circular path, from its center, certain force known as centrifugal force will arise, which pushes the object away from its center. So, due to this revolution round the nucleus, a centrifugal force will arise, and this force will push the electron away from the nucleus, so that this electron will escape from the nuclear attraction, which is known as centripetal force. The force which pulls the object towards its center is said to be centripetal force, and the force which pushes the object away from its center is said to be centrifugal force. Because of the nuclear attraction, there is a centripetal force. To overcome that centripetal force, the electron will revolve around the nucleus, and because of that revolution, a centrifugal force will arise, and these two forces are equal in magnitude but in opposite direction, keeps the electron at a specific distance from the nucleus. He explained like that. At that time, almost all scientists were accepted his proposal, but later on, after the development of these electromagnetic theories and all these theories, it was found that when a charged particle is revolving around an oppositely charged particle, it continuously loses energy. If it continuously loses energy, this electron path will be a circular path, and ultimately the electron will travel in a spiral path, and ultimately the electron should fall into the nucleus. But it was not happened. That means the proposal of Rutherford is applicable only when there is no charge in these two particles. That is, if nucleus is neutral and electron is neutral, Rutherford's proposal will be acceptable. But here, a negatively charged particle is revolving around an oppositely charged particle. So if a charged species is revolving around an oppositely charged species, it continuously loses energy. If it continuously loses energy, it should travel in a spiral path but not in a circular path. If it travel in a spiral path, in one day or other day, it should fall into the nucleus and the atom should decay, but it was not happening. So Rutherford was unable to explain this. That's why Rutherford's theory was failed to explain the structure of an atom completely. But the idea regarding the nucleus that was given by Rutherford is still stands for the science. So this is the main foundation that was laid by Rutherford to explain the structure of an atom.